everyone, my name is Alexa Wojtek, and I am the coordinator for the Middle West Tennessee Clean Fuels Coalition. We have created this video series to provide a deep dive into the world of alternative fuels and advanced vehicle technologies. Alternative fuels are an important part of our transportation sector. We hope you find this video series informative. Thanks for tuning in. More than a dozen alternative fuels are in production or are under development for use in alternative fuel vehicles and advanced technology vehicles. Government and private sector vehicle fleets are the primary users for most of these fuels and vehicles, but individual consumers are increasingly interested in them as well. Using alternative fuels in advanced vehicles instead of conventional fuels in vehicles helps the United States conserve fuel and lower vehicle emissions. So what makes these fuels alternative? Alternative fuels are derived from sources other than petroleum. Most are produced domestically, reducing our dependence on imported oil, and some are derived from renewable sources. Often they produce less pollution than gasoline or diesel. The U.S. Energy Information Administration's 2020 Annual Energy Outlook anticipates a steady increase in alternative fuel usage over the next 30 years. The projected increase of electricity use in transportation results from an anticipated rise in sales of new battery electric and plug-in hybrid electric light-duty vehicles, while the increase in natural gas consumption through 2050 stems from increased use of compressed natural gas to fuel heavy-duty vehicles such as freight trucks. As we have seen in Tennessee and in many other states nationwide, certain federal, state, or local incentives or funding programs, including the Volkswagen Diesel Settlement Environmental Mitigation Trust, the Federal Highway Administration's Congestion Mitigation and Air Quality Improvement Program, EPA's Diesel Emissions Reduction Act program, and more, can provide funding to offset the upfit or incremental cost of alternative fuel vehicles or infrastructure to help catalyze adoption of these technologies by both public and private fleets. The number of alternative fuel vehicle models grew consistently from 1991 to 2002, particularly as flex fuel vehicles, or FFVs, gained popularity. What's an FFV? FFVs have an internal combustion engine and are capable of operating on gasoline and any blend of gasoline and ethanol up to 83%. From 2002 to 2006, alternative fuel vehicle model variety dropped as manufacturers reduced the variety of FFVs available. The number of alternative fuel vehicle models then grew by 250% between 2010 and 2014 as the United States emerged from the economic recession. Over the next 4 years, the number of models reached an all-time high of 220 models in 2019. Subsidiaries of the big three U.S. manufacturers, or GM, Fiat Chrysler, and Ford, have brought nearly 2/3 of the alternative fuel vehicles to market over the past 29 years. Let's zoom out a bit and talk about the history of alternative fuels. Alternative fuels date back to the beginning of the car industry. In 1900, more than half of the cars on the road ran on steam, ethanol, or electricity-powered batteries. In fact, at the 1900 World's Fair, Rudolf Diesel, the inventor of the diesel engine, demonstrated his engine using biodiesel made out of peanut oil. In 1899, Thomas Edison began a sustained effort to develop a battery suitable for automobiles, just 4 years after the introduction of the first practical gas-powered car. Edison believed that an electrical storage battery could be developed that would prove more economical than gasoline. Back then, petroleum fuels were considered dangerous, and they were limited in supply. This changed in 1901 when oil was discovered at Spindletop Oil Field near Beaumont, Texas. Henry Ford introduced the inexpensive, high-quality, low-cost, gasoline-powered Model T in 1908. Just 1 year after Edison had perfected his battery, and about 2 years before Edison was ready to manufacture it on a large scale. By the time the Model T had gone into production, gasoline was firmly entrenched. Steam was in sharp decline, ethanol was relegated to occasional farm use, and electric vehicles clung to a dwindling city car market. The Model T captured the imagination of the American public and ushered it into the age of the internal combustion engine that is still present today.
Hi, this is Shauna Vasquez, Middle West Tennessee Clean Fuels. A vast array of pollution laws, safety regulations, and energy subsidies focused on petroleum were introduced beginning in the 1960s. The term alternative fuel first appeared in energy literature in late 1970s as a way to refer to non-conventional fuels, excluding all fuels refined from petroleum that are normally liquid at room temperature, such as gasoline. In the United States, the leading use of alternative fuels is not as standalone fuels, but as additives to petroleum-based gasoline and diesel fuel. For example, most of the gasoline sold in the United States is 10% ethanol. The first major government investment in alternative fuel was for the purpose of energy security and oil import independence. Beginning in the late 1970s, billions of dollars were spent on synthetic fuels, converting coal and oil shale into gasoline and diesel. When oil prices began to fall in the early 1980s, and it became apparent that the costs of producing synthetic fuels would remain well above that of petroleum fuels, such program efforts were abandoned. Over the last half century, alternative fuels have periodically benefited from public subsidies, ambitious government initiatives, and industry investments. Interest picked up in the latter part of the 20th century in response to poor urban air quality and environmental regulations. In 1995, alternative fuels comprised about 3% of all fuels consumed in the United States, 4.4 billion gallons versus 142 billion for gasoline and diesel. In 1992, the U.S. Congress passed the Energy Policy Act, known by some as EPACT, which established the goal of having alternative fuels replace at least 10% of petroleum fuels used in the transportation sector by 2000 and at least 30% by 2010. Even with subsidies and favorable regulations, alternative fuels face significant hurdles before becoming practical replacements for conventional fuels. The foremost hurdle is cost, followed by safety concerns, practicality and reliability, and finally, the development of infrastructure to support production, distribution, and retail availability of the fuel. Why use alternative fuels rather than traditional fuels like gasoline or diesel? Number one, public health and local environmental benefits. The combustion of traditional gasoline and diesel fuel produces significant emissions of harmful pollutants, including carbon dioxide, nitrogen oxides, carbon monoxide, and particulate matter. These pollutants can be harmful to human health and the environment. Nitrogen oxides, or NOx, can harm the respiratory system and is attributed to environmental hazards such as acid rain, deteriorated water quality, and particulate matter. Particulate matter, PM10 or PM2.5, meaning particulate matter that is 2.5 micrometers or less in PM2.5's case, can carry harmful toxins and is known to aggravate existing respiratory and cardiovascular issues. Volatile organic compounds, or VOCs, combined with NOx can produce ozone, commonly known as smog. Smog is damaging to the respiratory system as well as to plant life. Additionally, engines powered by gasoline and diesel fuels tend to be louder than vehicles that run on alternative fuels, producing harmful noise pollution in our communities. This can lead to noise-induced hearing loss, NIHL, high blood pressure, heart disease, sleep disturbances, and stress in humans and wildlife. Number two, why alternative fuels over traditional fuels? Energy security. In 2018, the United States consumed approximately 20.45 million barrels of petroleum each day, about 11% of which was imported. Because transportation accounts for nearly 3/4 of total U.S. petroleum consumption, using alternative fuels, many of which can be produced domestically, can have a major and direct impact on transportation. This not only supports the U.S. economy, but also helps strengthen emergency preparedness and resiliency through diversity of fuel options that can be leveraged in the event of a natural disaster, fuel shortage, or fuel supply disruption. Number 3 on why alternative fuels, fuel price and fuel economy. Fleets can experience significant cost savings by using alternative fuels, especially with things like electricity. With fuels like compressed natural gas, CNG, or propane, volume pricing plays into the price of a fuel, and fleets can secure a lower price per gallon if they opt to use more fuel per month. Specifically, both private and public sector fleets can often secure a long term fuel contract to purchase fuel at a price anywhere from 1 to 50% cheaper than the non bulk cost. Long term fuel contract prices will ultimately vary depending on the volume of anticipated fuel use and the size of the infrastructure tank that will need to be filled. As an example, while the national average retail fuel price for propane is a little less than $4 per gallon, as illustrated in this graph appearing on the screen now, we have seen untaxed propane autogas numbers for local government fleets in the $1.30 to $1.60 per gallon range. For example, the Clarksville-Montgomery County School System reported a 2018 propane use price of $1.34 per gallon. With regard to non-bulk fuel prices, the U.S. Department of Energy's quarterly alternative fuels price report is a great example and resource for anyone interested in alternative fuels. It details retail at the pump sales prices for each alternative fuel contained within the report.
Ethanol is a renewable fuel made from plant material known as biomass. More than 98% of gasoline in the United States contains ethanol in the form of E10, which is a blend of 10% ethanol and 90% gasoline. Blending ethanol into gasoline helps oxygenate the fuel and reduce air pollution. E85, also known as flex fuel, is another gasoline ethanol blend of up to 83% ethanol that can be used in flex fuel vehicles. In the United States, 94% of ethanol is produced from the starch in corn grain. There are several steps required to convert ethanol into a vehicle fuel. Number 1, the biomass feedstock, or the raw plant matter, must be grown, collected, and transported to an ethanol production facility. The feedstock is then converted to ethanol at the production facility and then transported to a fuel terminal by rail, truck, or barge. The ethanol is then blended with gasoline at the fuel terminal to make ethanol blends such as E10, E15, and E85, and distributed by truck to fueling stations. Using ethanol as a vehicle fuel has measurable greenhouse gas emissions benefits. Carbon dioxide released when ethanol is used in vehicles is offset by the carbon dioxide captured when crops used to make the ethanol are grown. As a result, ethanol and gasoline-capable flex fuel vehicles running on high-level blends of ethanol produce less net carbon dioxide emissions than conventional vehicles per mile traveled. A study by Argonne National Lab found that when these entire fuel life cycles are considered, using corn-based ethanol in place of gasoline reduces life cycle greenhouse gas emissions on average by 34%, depending on the source of energy used during ethanol production. Using cellulosic ethanol, which is ethanol made from non-food-based feedstocks such as crop residues, wood residues, and industrial and other wastes, provides an even greater benefit, reducing greenhouse gas emissions by up to 108%, depending on cellulosic feedstock type and conversion processes. In addition to ethanol having a higher octane number than gasoline, providing increased power and performance, ethanol production creates jobs in rural areas where employment opportunities are most needed. According to the Renewable Fuels Association, ethanol production in 2017 accounted for more than 71,900 direct jobs across the country and contributed $45 billion to the gross domestic product and $24 billion to U.S. household income. Flex fuel vehicles, which can operate on E85, gasoline, or any blend of the two, are available nationwide as standard vehicles with little to no added incremental costs, making them an affordable alternative fuel vehicle option. In addition, there's a number of different examples of ethanol use here in Tennessee. For example, Franklin Transit, which is part of the TMA group, operates fixed route and transportation on-demand services in Franklin, Tennessee. Of the 16 vehicles in their entire fleet, 12 are shuttles that run on E85, and they have 2 large buses that run on B20, and 2 are hybrids. Over 35% of their fuel use is purely renewable fuel. Biodiesel is a renewable, biodegradable fuel manufactured domestically and used in conventional diesel engines, directly substituting for or extending supplies of traditional petroleum diesel. Biodiesel is produced mostly from virgin vegetable oils, such as soybean, or used vegetable oils or animal fats. Like ethanol, there are various blends of biodiesel with petroleum diesel. B5, which is 5% biodiesel and 95% petroleum diesel, requires no special labeling to denote the blend, but blends of B20 and higher are considered an alternative fuel under the Energy Policy Act of 1992. The use of biodiesel does not require a new engine or vehicle. Biodiesel blends up to and including B20, which is 20% biodiesel, can be run in almost any standard diesel engine on the roads today. Using biodiesel reduces emissions because carbon dioxide released from biodiesel combustion is offset by the carbon dioxide absorbed from growing soybeans or other feedstocks used to produce the fuel. The amount of carbon dioxide offset varies by the blend of the biodiesel, however. For example, using B20 instead of petroleum reduces CO2 emissions by around 15%, whereas using B100, which is pure biodiesel, instead of petroleum would reduce emissions by about 74%. Biodiesel also causes far less environmental damage than petroleum diesel if spilled or released into the environment. It is safer than petroleum diesel because it is less combustible. The flash point for biodiesel is higher than 130 degrees Celsius compared with about 52 degrees Celsius for petroleum diesel. Biodiesel is safer to handle, store, and transport. Biodiesel can also improve engine performance due to its lubrication properties and higher cetane number, which decreases the ignition delay when starting the engine. Finally, biodiesel can be domestically produced, which minimizes risks of trade deficits, supply disruption, and price changes that come with reliance on foreign petroleum. Biodiesel production spans across the United States and has grown to more than 125 plants with the capacity to produce 3 billion gallons annually. In 2018, the U.S. biodiesel industry produced 2.6 billion gallons of biodiesel. But production isn't only about gallons produced, but also about the economic benefits to the U.S. The biodiesel industry supports more than 62,000 jobs and generates billions of dollars in gross domestic product, household income, and tax revenue. The industry's economic impact is poised to grow substantially with continued production increases. The industry supports jobs in a variety of sectors, from manufacturing to transportation to agriculture and service. Just like with other alternative fuels, there are a number of examples of fleets right here in Tennessee that utilize biodiesel. The city of Sevierville began to test and use biodiesel way back in 2004. The city has used B20 in all their diesel vehicles, including for their fire department fleet, ever since. Great Smoky Mountains National Park uses B20 in their diesel vehicles, and additionally, Sullens Transport, a commercial trucking company, produces and uses B99 year-round in their Class 8 food-grade tankers, which transport raw milk and other dairy components throughout the Middle Tennessee area at roughly 15 to 20 loads per day.
So now we're moving on to electric vehicles, one of the most popular consumer choices for personal commuter vehicles, as well as can be used in medium and heavy duty vehicle applications. Electric as an alternative fuel, it's really kind of a growing field within alternative fuels in general. So very exciting stuff to learn here. Electricity can be produced from a variety of energy sources, including from fossil fuels such as coal, oil, and natural gas, as well as from clean energy sources such as nuclear power, hydropower, wind power, solar power, and hydrogen. Vehicles running on electric power have zero tailpipe emissions, and depending on the energy source used to create the electricity, hybrid and plug-in electric vehicles can have significant emissions benefits over conventional vehicles. In geographic areas that use relatively low polluting energy sources for electricity generation, electric vehicles typically have a significant emissions advantage over similar conventional vehicles running on gasoline or diesel. In regions that depend heavily on conventional fossil fuels for electricity generation, for example, coal, electric vehicles might not demonstrate as good of a well-to-wheels emissions benefit. The following graph details the annual carbon dioxide or CO2 emissions for all electric vehicles, plug-in hybrid vehicles, and gasoline passenger vehicles in Tennessee, based on 2017 net electricity generation for all sectors in Tennessee from the U.S. Energy Information Administration. Annual emissions per vehicle are 71%, 52%, and 45% lower for the all-electric vehicles, plug-in hybrid electric vehicles, and hybrid vehicles respectively, as compared to gasoline vehicles. There are two main categories of electric vehicles. First, there are hybrid electric vehicles, also called HEVs. These are conventional gasoline vehicles that have an electric motor that stores energy in a battery. HEVs are fueled with liquid fuels like gasoline, but use batteries to recapture energy otherwise lost during braking, ultimately boosting fuel economy. There is no external charging used on HEVs, and an example of one very popular across the country and the world is the Toyota Prius. A second type of electric vehicle is a plug-in electric vehicle, or PEV, which uses electric vehicle supply equipment, EVSE, or charging infrastructure to plug into and recharge a battery. These vehicles can draw electricity directly from the grid and from other off-board electrical power sources, for example, solar panels, and then store it in onboard batteries. PEVs can be hybrid or they can be all electric. Plug-in hybrid electric vehicles, or PHEVs, use batteries to power an electric motor as well as another fuel, primarily gasoline or diesel, used to power an internal combustion engine or other propulsion source. PHEV batteries can be charged by an outside electric power source, by the internal combustion engine, or through regenerative braking. Many popular traditional vehicle models are also offered in PHEV form, including the Chrysler Pacifica, Ford Fusion, Kia Optima, and Range Rover. The most popular PHEV sold across the world was the Chevy Volt with a V, Volt. That model is no longer available, but that's probably a good example of what you might have encountered out in the wild on the road, as a good example of a PHEV. The other type of PEV is an all-electric vehicle or battery electric vehicle, BEV. BEVs are powered solely by electricity. The vehicles use a battery pack to store the electrical energy that powers the motor. BEV batteries are charged by plugging the vehicle into an external electric power source. Popular examples of BEVs include the Nissan Leaf, which is actually made and assembled in Smyrna, Tennessee, as well as the Tesla Model S. For regards to other types of electric technologies, it's really important that we also discuss how charging infrastructure is available and how its availability might vary based on where you are, what kind of charging you require for your specific vehicle needs, etc. So there's different charging levels for electric vehicles, the slowest being level 1 charging, which uses alternating current, or AC, at 120 volts. Level 1 charging will provide 2 to 5 miles of range per hour of charging. Like I said, this is the slowest available. Because of this, level 1 is ideal for residential charging, where vehicles often sit for several hours overnight, really, between uses. Most, if not all, PEVs will come with an AC level 1 charger cord. You'll get it in the car when you purchase it, so that no additional charging equipment would be required for drivers planning to charge their vehicles at home. At one end of the cord is a standard 3-prong household plug, and on the other end is a SAE J1772 standard connector, and that plugs directly into a port on your vehicle. Any electric vehicle can use level 1 charging. Level 2 charging uses alternating current, again AC, at 240 volts. This will provide 10 to 20 miles of range per hour of charging. For that reason, level 2 is typically ideal in residential and commercial applications. Unlike the simplicity of level 1 charging, where the cord comes with the vehicle and it can go into just a regular household looking outlet, level 2 charging does require the installation of a charging unit, and that can sit on a pedestal, it can be mounted to the wall. Other types of options are available, but those are the two most common. And they require a dedicated circuit of 20 to 100 amps, depending on the make and model of the vehicle and how fast it can draw electricity to charge its battery. Because the other thing is, when it comes to electric vehicle charging, the charge rate is not just determined by the equipment that's, you're plugging into your car. It's also established by the charger that's on board the vehicle and provides electricity to the battery. So there's kind of two timing equations here. Level 2 charging does use the same SAE J1772 connector. That's the same as the level 1 one, so they'll look exactly the same. And again, any electric vehicle can use level 2 charging. Finally, that DC fast charging is kind of the next step up, and that uses DC, direct current, as opposed to AC, alternating current, at 480 volts. DC fast charging provides 60 to 80 miles of range per 20 minutes of charging. Its rapid charge capability makes this equipment ideal for commercial applications, especially along heavily trafficked corridors such as interstates or U.S. highways. There's 3 different types of DC fast charging connectors. Again, that's the thing at the end of the cord that you plug directly into the vehicle. Those standards include CHAdeMO, SAE combo, and then Tesla has its own proprietary connector that's unique to Tesla vehicles and Teslas alone. It's important to know which type of charger is compatible with each vehicle. So a lot of DC fast chargers actually will provide both a CHAdeMO and an SAE combo connector. In short, you're going to kind of have to know your EVs, but a lot of, Nissans, they use CHAdeMO. SAE combo is favored by manufacturers like BMW and GM. And of course, there's other manufacturers out there, but those are kind of some big ones to just know offhand. Many DC fast chargers, like I said, they'll provide both of those connectors for you, so that you're never encountering a situation where you drive up and you can't use the charging infrastructure that is available on site. And then, while Tesla does have its own proprietary connector, like we were talking about, they also have their own proprietary charging network. So there's an entire Tesla supercharger network outside of these publicly available DC fast chargers that work for any Tesla model vehicles. And then they also do sell adapters for the Teslas. So you can use the Tesla supercharger network if you're in a Tesla, or you can also invest in an adapter for the Tesla plug to be able to connect to the other DC fast charging standard types. SAE combo, I believe, is the one that's currently most available for Teslas. Finally, some vehicles are able to be charged wirelessly through inductive charging. This type of charging uses an electromagnetic field to transfer electricity to a PEV wirelessly without a cord. It uses alternating current at 240 volts. Similar to level 2 charging, wireless charging typically provides 10 to 20 miles of range per hour of charging and is ideal for both residential and commercial applications. Wireless charging was recently introduced commercially for installation as an aftermarket add-on for certain vehicles, and it is not yet as common as the other types of charging that we previously mentioned. And I will say, in Tennessee, this kind of wireless charging application, we've actually seen it be quite successful in large vehicles. So out in Chattanooga, the Chattanooga Area Regional Transportation Authority, or CARTA, has a series of long-range battery electric transit buses, that they charge with inductive charging out of their downtown depot. And that actually will restore power a lot faster than what I just referenced. That charges that transit bus in just a few minutes to make sure that it continue on route service throughout the day. So there's lots of different exciting things that are happening for electric vehicles and charging infrastructure in Tennessee. And there's always more to learn. So definitely refer to Tennessee Clean Fuels, Middle West Tennessee Clean Fuels, if you want to learn a little bit more about that. PEVs lack many of the complex moving parts found in a gasoline engine, which would be maintained over time. As an example, if you're talking about a battery electric vehicle, BEV, those don't require oil changes. As such, lifetime maintenance costs for those types of vehicles are expected to be a lot less than conventional gasoline vehicles. A 2017 report by the Florida Solar Energy Center estimated that maintenance costs for an electric vehicle over a 10-year period are in the range of $4,500 to $7,500. Compare that to a legacy gasoline vehicle that typically has a 10-year maintenance cost of $6,700 to $7,700, or within that range for, again, conventional gasoline passenger vehicles. Fuel costs are also significantly less for electric vehicles. According to the U.S. Department of Energy's e-gallon calculator, it costs 97 cents per gallon gasoline equivalent in electricity to fuel a car in Tennessee. 97 cents per gallon. Think about that and compare that to the average cost of gasoline gallons for an actual gasoline car. That's $2.69 per gallon in some places in Tennessee. Although fuel costs for hybrids and electric vehicles are lower than for similar conventional vehicles, purchase prices for these types of vehicles can be higher. Currently, initial costs can be offset by fuel cost savings and federal tax credits where they're available. Some other considerations for electric vehicles, such as limited availability of public charging infrastructure in some places, uncertainty of battery life, potentially limited driving ranges depending on the vehicle models that you're selecting, and how that might contribute to range anxiety. These are all things that are things that we need to consider before adoption. These concerns, though, they're likely to be addressed as the market for electric vehicles grow, and it is growing. In fact, in Q4 of 2020, we already had 11,000 personal electric vehicles registered in Tennessee. And it might seem like you don't see them out in the wild, but they're definitely there, and they're growing in number fairly quickly. In fact, there's several major manufacturers, including GM, Volkswagen, and like I mentioned earlier with the Nissan Leaf, Nissan, who are all producing or will be producing in the next few years passenger electric vehicles for the U.S. auto market, and they'll be producing them in Tennessee. So this is definitely a growing market, and a lot of the things that people might have concerns about now, like I said before, batteries, charging infrastructure, having new models available that might go further distances. Those are all things that are really, they're here for a lot of people, or for those that are in certain areas where maybe charging infrastructure, there's not as much of it, or they're looking for a certain vehicle in a certain vehicle segment and price range for them. These are things that are coming. So definitely very interesting to look out for on the electric vehicle space. Again, as that electric vehicle market segment continues to grow, prices are likely to decrease. The prices of the vehicles decrease as production volumes increase. Battery technologies do continue to mature, and increased EV availability and demand will drive charging infrastructure development across the country. Some examples of how EVs are being used in Tennessee. There's a whole lot of different types of EVs that we have available in Tennessee right now. I already mentioned CARTA and their electric transit buses, but they're certainly not the only transit agency in Tennessee that's adopted electric technologies. On the smaller side, when we're talking about more passenger vehicles, a good example of EV adoption would be the Metropolitan Government of Nashville in Davidson County, which maintains a 13-vehicle PEV rideshare program for local government employees to use when conducting business around town. And if you have an EV, or if you've ever driven to certain Metro Nashville-owned parking garages and other pieces of property in and around Nashville, you'll actually be able to see that as a side benefit of this rideshare program, there's an awful lot of charging infrastructure that's publicly available for free. So definitely take a look at Metro Nashville as kind of a great example of providing a benefit to their employees, as well as having that benefit kind of extend to the public in certain areas to increase EV adoption as a whole in the metro area.
Natural gas, a domestically produced gaseous fuel, is readily available through existing utility infrastructure. Whether produced through conventional or renewable methods, natural gas must be compressed or liquefied for use as a transportation fuel. Currently, in the US, about 27% of the energy use comes from natural gas, but only 1% of this is used for transportation. The vast majority of natural gas in the United States is considered a fossil fuel because it is sourced from buried organic materials that have been compressed by extreme heat and pressure over millions of years. Most natural gas is drawn from wells or extracted in conjunction with crude oil production. Natural gas can also be mined from subsurface porous rock reservoirs through extraction processes, such as hydraulic fracturing or fracking. Once extracted, the gas is separated from free liquids such as crude oil, hydrocarbon condensate, water, and entrained solids. The separated gas is further processed to meet specified requirements. For example, natural gas for transmission companies must meet certain pipeline quality specifications with respect to water content, hydrocarbon dew point, heating value, and hydrogen sulfide content. The United States has a vast natural gas pipeline system, which can quickly and economically distribute natural gas to and from almost any location in the lower 48 states. Gas is distributed using 305,000 miles of transmission pipelines, while an additional 2.2 million miles of distribution pipes transport gas within utility service areas. Although the United States has an extensive natural gas distribution system in place, vehicle fueling infrastructure is limited. The vast majority of the nation's compressed natural gas, or CNG, supply is distributed via the existing natural gas distribution system. Most natural gas fueling stations dispense CNG, which is usually compressed on site. CNG is used in light, medium, and heavy-duty vehicles. Liquefied natural gas, or LNG, is produced by purifying natural gas and supercooling it to negative 260 degrees Fahrenheit to turn it into a cryogenic liquid. During the process known as liquefaction, natural gas is cooled well below its boiling point, removing most of the extraneous compounds found in the fuel. LNG is suitable for medium and heavy-duty trucks that require longer ranges because liquid is denser than gas, and therefore more energy can be stored by volume. Although both CNG and LNG can be used in vehicles, CNG vehicles are more common. While most natural gas fueling stations in the United States dispense CNG, a limited number of LNG fueling stations are available. This is because of LNG's relatively high production cost, as well as the need to store it in expensive cryogenic tanks, limits its use in commercial applications. Interestingly, Tennessee has some of the highest LNG use in the country, attributed primarily to UPS, which has a private refueling station in Nashville. Renewable natural gas, or RNG, is a pipeline quality gas that is fully interchangeable with conventional natural gas and thus can be used in natural gas vehicles. RNG is essentially biogas, the gaseous product of the decomposition of organic matter that has been processed to purity standards. Common sources of RNG include biogas sourced from landfills, wastewater treatment plants, and livestock operations. Like conventional natural gas, RNG can be used as a transportation fuel in the form of compressed natural gas, or CNG, or liquefied natural gas, LNG. RNG qualifies as an advanced biofuel under the Renewable Fuel Standard. Did you know there are 3 publicly available RNG stations in Tennessee? Piedmont Natural Gas's station in Nashville, Memphis Light Gas and Water's station in Memphis, and American Natural Gas's station in Fayetteville. Light-duty vehicles running on conventional and shale natural gas can reduce life cycle greenhouse gas emissions by 15% as compared to gasoline, 84% if running on RNG. In addition, because CNG fuel systems are completely sealed, CNG vehicles produce no evaporative emissions, which are emissions that escape from the fuel tank and are released into the atmosphere. Life cycle GHG emissions tied to CNG are predominantly the result of production phase fuel leakage. What's an example of a fleet that uses natural gas in Tennessee? Waste Management is the single largest fleet user of compressed natural gas in Tennessee. As of December 2018, they had 117 dedicated CNG refuse trucks that were used in commercial and residential refuse collection in the Nashville and Jackson areas. In 2018, these vehicles utilized 1.4 million gasoline gallon equivalents of CNG. Propane, also known as liquefied petroleum gas, or LPG, or propane autogas, is a cleaner burning alternative fuel that's been used for decades to power light, medium, and heavy-duty propane vehicles. Propane autogas is the world's 3rd most commonly used transportation fuel, behind gasoline and diesel. Primary use cases for propane include school buses, light-duty passenger trucks, and medium-duty delivery vans. Propane has a high octane rating, making it an excellent choice for spark-ignited internal combustion engines. If spilled or released from a vehicle, it presents no threat to soil, surface water, or groundwater. Propane is produced as a byproduct of natural gas processing and crude oil refining. The vast majority of propane consumed in the United States is produced here and distributed via established pipeline infrastructure. Propane fuel has a lower carbon content than conventional gasoline and diesel fuel. When used as a vehicle fuel, propane can offer life cycle greenhouse gas emissions benefits over conventional fuels, depending on the vehicle type, age, and drive cycle. When Argonne National Laboratory's GREET model is used to evaluate vehicles running on propane, it indicates that propane use reduces greenhouse gas emissions by nearly 13% as compared to gasoline. So what are some fleets that use propane in Tennessee? The city of Kingsport operates 100 propane-powered vehicles, of which roughly half are police cars. Work trucks used by varying departments comprise the rest of the fleet, in addition to several propane-powered zero-turn lawnmowers. The city trained its workforce to be able to perform its own conversions of vehicles to run on propane, reducing upfit and maintenance costs. In Clarksville, the Clarksville-Montgomery County School System operates more than 58 propane-powered school buses. The fleet has seen maintenance costs drop by 50% after switching to the alternative fuel.
Now, we all know that alternative fuel vehicles can be purchased new. But, alternatively, existing vehicles that run on conventional gasoline or diesel can be converted to operate on an alternative fuel such as propane, natural gas, or electricity. These converted vehicles can run on several different configurations depending on how the fuel is incorporated and used to power the vehicle. The first configuration is for vehicles and engines to be converted to dedicated configurations, where they operate exclusively on one alternative fuel. The second type of configuration is to be converted to a bi-fuel configuration, where they operate on two different fuels. Each fuel will have a separate tank and separate fuel system, one for conventional fuel and one for some alternative fuel. In this case, either fuel can be accessed by simply flipping a switch. And the third configuration is dual fuel. This configuration is one where two fuels can be used simultaneously. For example, a heavy-duty natural gas vehicle that uses a small amount of diesel fuel for ignition assistance is a dual fuel system. Any change to the manufacturer's original vehicle or engine design is a potential violation of the Clean Air Act and can cause some problems, including increased emissions. Therefore, the U.S. Environmental Protection Agency, or EPA, has established protocols through which conversion manufacturers can demonstrate that emissions controls in the converted vehicle or engine will continue to function properly and pollution will not increase as a result of the conversion. The applications for alternative fuel vehicles are endless. Wherever traditional gasoline and diesel vehicles are used, there is the possibility to implement an alternative fuel vehicle in its place. There is no one-size-fits-all with alternative fuels. Each one has its strengths and its weaknesses, and therefore is better suited for certain applications over others. Alternative vehicles can also serve in off-road applications such as mowers, agriculture, and landscaping vehicles. Example of this right here in Tennessee are in both the city of Knoxville and Great Smoky Mountains National Park, where both use propane-powered mowers. All across the alternative fuel spectrum, there are a wide variety of career opportunities available. One of these is the Clean Cities Network, which is a network of around 100 coalitions across the country funded by the US DOE that supports and promotes use and implementation of alternative fuels and alternative fuels technologies, and supports policy that promotes it as well. There are two coalitions here in Tennessee. One is the Middle West Tennessee Clean Fuels Coalition, which serves the Middle West Tennessee region, and the East Tennessee Clean Fuels Coalition based in Knoxville that serves East Tennessee. There are also many opportunities to work at the local, state, and federal government levels, such as right here for the state of Tennessee, within research and academia, such as at the National Transportation Research Center in Oak Ridge, for policy and or advocacy-oriented nonprofits, such as the Southern Alliance for Clean Energy. And beyond this, there's many sustainability offices, planning organizations, infrastructure or equipment companies, technicians, repairs, diagnostic companies, automotive manufacturing or related parts suppliers, and fleet management companies that all have their stake in the alternative fuels world. We thank you for watching this video. We hope that it was a great introduction to the world of alternative fuels and that you learned a lot from it. I'm going to leave you with a few additional resources outside of this video that can be of assistance in exploring the rest of the world of alternative fuels and learning more about the different fuel types, their applications, and their impacts. The first one is the Alternative Fuel Life Cycle Environmental and Economic Transportation Tool, or AFLEET for short. What this tool allows you to do is take a look at the different economic and environmental impacts of different fuel types and different vehicles of those fuel types across various applications. Next is the Alternative Fuel Vehicle Cost Calculator, which helps users determine the cost of purchase and the cost of ownership of different alternative fuel vehicles of different fuel types. And finally is the Alternative Fuels Data Center Station Locator, which is a US-wide map that allows users to see publicly accessible refueling stations of all fuel types in their area or throughout the country, and allows users to map trips across large stretches of area and plan where they're going to stop to refuel.